My name is Tim Delesio, and I am the CTO over at Techolution. And I'm here today to talk about microservices and containers. So before I get too deep in there, let me tell you a little bit about Techolution. Techolution is a company that's been around for about 5 years now. We're a premier GCP partner. We're headquartered in New York City. We have an office in Jakarta, in Singapore, in Mauritius, and in India. We really focus on hybrid cloud and application modernization. And we've been doing Anthos deployment since its announcement since last April. We have a lot of dedicated engineers and different COEs that has really formed an assembly line to help companies transform. So before I get too deep into microservices, I want to talk a little bit about history. Before we find out where to go, let's talk where we've been and what the application landscape has looked like over the years. So let's start in the early 80s. That's pretty much when it all started. And anything really before the 80s, it doesn't really matter anyway. A lot of the computers were just talking together. There was just network protocols, a lot of work in academia and things like that. But towards the end of the 80s, we started to see some static HTML and some more application, just informational stuff that universities and academia were using to help spread the use of information. And then as we got towards the end of the 90s and the mid to end of the 90s, this is really when we start to see the birth of the web. We had thin clients coming up. We had applications that were mostly client-facing. Technologies like JavaScript and CGI and XML started to emerge. And we really started to get more of a user experience through forms and through some user input and whatnot. By the end of the 90s, in the turn of the century, this is really the birth of the internet as we know it. You started to get the real web applications that come out, your SOA, service-oriented architectures, your EJBs, your ESBs, your servlets and JSPs, and all your backend code that actually perform real application function. And this is really where the monolithic applications started to come together. You had single-page apps and other things that drove a lot of this work together. And then it's very interesting because we kind of see this trend where everything started as split with EJBs, and then all of a sudden we started to combine things back together because we wanted to reduce the dependencies out there and make these apps simpler. But by accident, we created these monolithic applications. And now you're starting to see the reverse of it in the rise of microservices, where we're starting to break apart these applications and really start to deploy them out. So, first, why microservices? Why do we even care about them? And why is everybody interested in deploying them? So first, what are some of the benefits? Why do we even, why do we want to even get there? So, if you were going to change your car, right, would you use a hammer to change your tire? I mean, no, you want to make sure you use the right tool for the job. You want to use a jack, and you want to make sure you got a lug nut to take off the lugs. So it's the same thing with microservices. You want to choose the right technology that fits the right application. If it's a Java application, or if it's a functional programming language, choose the right application that fits the job. And then this kind of bleeds into the replaceability of it. A lot of these applications over the years have started to accumulate all this technical debt, all these applications that are out there that are very difficult to go and replace. So once you get into the microservices mindset, if you want to swap out just your application, you can easily take that small little piece, cut it out, and then replace it with something else. This really reduces your technical debt footprint. And with the, going back to my history lesson here, if you're talking with a monolith, and when you wanted to scale out that monolithic application, you would have to scale out the entire thing. So you would have to replicate all those big, huge pillars in multiple places. And that was the only way you could really scale out and get a lot more out of your application. With microservices, they're really built to scale. So imagine taking out your monolith, breaking it into smaller pieces, and only scaling out the pieces that make sense. For instance, if you have a login page, for instance, that generates a lot of user activity, and that's coupled with some of the static pages, or maybe the contact us, or the less likely pages that you really don't hit. You want to make sure you're only scaling out that piece that really is getting all the attention. And obviously that takes into account a lot of getting a lot more density out of your servers. So if you're able to just scale that small piece instead of all those big pieces, you're really leveraging a lot of your infrastructure a little bit better. Ease of deployment and speed of innovation. And this is really probably one of the biggest driving factors why people want to go to microservices in general. You have all these nimble startups that come and are competing with more of these legacy and enterprise and older applications, and they're really struggling with getting changes out the door. A good example of this is that I consulted with one of our customers, one of the biggest banks in the world, and they were doing essentially quarterly releases. So think of that. They could only get out changes once a quarter. And they had all these applications that were basically just all coupled together and very tight together. So in order to make a change, they would have to get the entire company, the entire organization, to sit together and figure out all these complex matrices of what touches what, and how these applications interact. And when you have this situation, if you miss that deadline, you got to wait a whole another quarter to get the releases out. With the microservices, and what they ended up doing was they were able to take those quarter releases and get it down to bi-weekly. So they were doing a release every other week, and they were only changing the services that they really cared about. Once you have all these microservices too, you can start to do some organizational alignment. If you have a team that has an expertise in this one domain, you can have them do a set of microservices that they just control, and that's it. And a big thing is, everything breaks at some point in time. Everything it fails, whether it's a microservice or a monolith. And if you design for failure in mind, you're basically trying to get ahead of everything. You can do things like chaos testing, where you're actually purposely trying to get things to fail just so you can see how they react. Because if you know how it reacts when it fails, you can get in there to fix it right away. So, why doesn't just everybody just move to microservices? Why don't we just shut all the applications down and do it? And Martin Fowler is probably one of the biggest proponents of this. He came up with this phrase, microservices are not a free lunch. It's not like that any application can just go out and get there. There are so many system complexities and distributed systems. When you start to break up your application into smaller chunks and split it out and have pieces feeding into it, just imagine all the complexities that you're introducing. If you can see my screen here, if anybody knows what this is the Microservice Deathstar, if you will. In each one of these little green dots on the circle here are all microservices. And every one of these lines is a communication point between microservices. Just look at the vast number, and this is what this is at Netflix. Just imagine what all these different services are calling. And imagine if something broke here, or just even releasing this. If like this microservice right here broke, how would you know? You can't even see the lines of this. How would you possibly know where it broke? So this is why DevOps and DevOps skills are so important in this mindset. You need to make sure that as you're pushing and testing these, that each one of these microservices has gone through rigorous testing. It's scanned for vulnerabilities. It's checked for best practices. It goes through the ringer to make sure that this microservice isn't going to break any other microservice. And then you always can fall back on your previous statement where you are actually building to fail. So if you know that these are going to fail eventually, you have a plan and a mitigation way so that when they do, you know how to go ahead and fix them. And then when they do fail, you need a way to monitor them, to trace them, to log them, to debug them. So tracing and other things are rather difficult, and there are tools that help a lot with this. And myself, I'm a developer. I've been developing for almost 20 years now. So one of the things that always comes to my mind is developer environment, and this kind of leads to your testing as well. Imagine taking all of these services and running it on your MacBook Pro. It's not going to happen. Just imagine how much each one of these services consumes. So getting a full environment to stand up is nearly impossible at the local level. So couple that with the fact that you're trying to debug them or run them, it makes it a very, very interesting challenge. So, how do we rise above these challenges? What is some of the ways that we can actually go out and, get around a lot of these problems? Going back to Netflix, they are one of the grandfathers here of these patterns and some of these technologies that out. Starting from the top here, but service discovery. So service discovery allows you to essentially become a DNS for microservices. So if you have two services that communicate with each other and you want A to call B, one of the ways you could do it is you could hard code the IP address and the port into the microservice. And obviously that doesn't make much sense, because in the world of the cloud, that service is going to fail. It's going to be disposed of. It's going to spin up a new instance. You need a better way that A can call B. So that's where service discovery comes in. And you basically say, hey, I want to call B. So you talk to the service discovery. You say, hey, service discovery, I want to talk to service B. Give me a available service. And the service discovery will look in the pool of available services and return you with a available server. And this allows you to keep track of which servers are healthy and where they're located. And if they die, new ones can come up and register themselves and deregister themselves. Gives it a nice way to keep everything nice and neat and being able to track it. And again, go back to my Deathstar. Imagine if you have A equal B equals C and you have a failure in microservice C. Eventually those connections are going to stack and that application is going to crash. And then all those connections coming in are going to stack, and then that application is going to crash. So you see this cratering effect where it takes down your entire application. I relate this to your house. If you have a short circuit in like your electrical line in your house, does your house burn down? No, definitely not. There's a circuit breaker in there that'll get there and it'll trip, and it will force that whatever those lights are on in that circuit to crash and won't burn down your house. Back in the days before that, your house will literally burn down, and that's what a monolith does if it has an application fault. It burns down, the whole thing crashes. Bulkheading is very similar to that, but it kind of takes the concept of taking all your connections into one place. And a good example of this is, when your front-end code makes a connection to your back-end code. All your connections are through a central place, so you have a chance to control, who has access. You can throttle connections, you can do security, SSL termination, those kind of things. So it gives you a nice way to kind of do a full control over all the stuff that's coming in. And then going back to the environments, so everybody tests in a dev, you usually have a qual, maybe a pre-prod and a prod. And each one of these environments has its own dependencies. So like your dev instance, for instance, doesn't talk to your production database. So they usually have your dev database as well. So in order to solve for that, without hard coding those dependencies into your code, you can use external configuration. And you can separate all the configurations that exist in the code and the systems they talk to, and then treat them as essentially variables. So when you go from dev to qual, the code is the same exact. So you've already tested it in qual and dev, it's good. You don't want to be going in there and monkeying with things and changing things. And all you want to do is swap out the variable and point to a new system. So external configuration takes care of this and allows you to bring it all together. And then I talked about tracing and logging, but there are tools out there that can set up these traces, these unique IDs. So when a transaction comes in, it can use the same transaction for every microservice it hits, so that if you need to see the full path that it took, you can just search for that trace ID and you can see the full path that it took to get there. And chaos engineering and building to fail. That's just so important. So what are some good indicators that you actually have a good solid microservice architecture? So not going to get too much into these, but loose coupling, you want to make sure these are as loose as possible. You don't want your applications to be tied. You don't want that big bank issue where everything is tightly coupled and all of a sudden you're locked into specific releases and specific release cycles. You want to make sure that everything is highly cohesive, very well working together. You need very clear bounded contexts. So in this my little example here, you have a product context and a shipping context, but they both share a product domain, which is just copied between the two. But these are different completely contexts that can be split. So when you see more of these, you can start to see a very mature microservice organization. You need very good pipelining, automated testing, scanning. More automated processes is better. Instead of thinking of 10 to 20 services, think thousands. In order to handle that kind of load, you really, really need automation in place. And then if you're not familiar with 12-factor, 12factor.net, 12-factor application, these are basically 12 governing rules that exist to define a good microservice architecture, which I don't want to bore you and go through with these, but these are, the closer your application is to these, the more natural fit it is going to be in the microservice world. So talked a little bit, what it looks like, but how do we get there? What are the ways we can move to this architecture? Because I'm sure you're all wondering that. But before you even get there, you should first assess what your current landscape looks like. What does your organization look like? What does your team look like? Do you have a lot of business units that are siloed? Do you have teams that are clashing on code and you're constantly overwriting each other's changes? What does your skill set look like? I mean, are you COBOL and Fortran developers? Are you in some sort of modern or at least semi-modern language? I mean, are you able to make that jump to the microservice world and actually support a more modern language? What is your maturity level on your testing? Are you doing a lot of QA and manual testing? If you are, it's going to be a very hard transition. I mean, granted, there'll always be a place for manual and integration testing, but you really need to make testing, TDD, test-driven development. Testing should be thought of first, and that should really come as part of your development cycle and part of your DevOps cycle. So, you should always think automation and, what in my system can I automate? And if the answer is I can't automate it, should be why can't I automate it? Because you should always try to come up with some way. What does your system dependencies look like? I mean, are you talking to all these legacy old mainframe systems, or are you talking to databases and NoSQL databases? I mean, that goes a long way. If you have to talk to these green screen applications and some of these older systems, I mean, you're going to have to do something because the modern interfaces just doesn't exist in this code. I mean, those systems were never thought of in this part of architecture. And then really, what is driving your need for microservices? Is it just somebody up the chain or some cool buzzword you heard of, or is there actually a real business reason for going there? I mean, don't get me wrong, monolith applications do have their purpose. I mean, you don't want to get into a place where you have all these nano microservices, but at the same time, you don't want these giant monolithic applications too. But I mean, if it's a application that's smaller or in well defined and has its own release cycle, and then it might be a good place where you should think of keeping your monolith. So where do we start? So how do we get going with this? Well, one of the easiest ways is really just start creating it. If a new business requirement comes in or a new feature from the business that looks like a good place that isn't highly coupled and highly interacting with the current system, just start new. Just start creating microservices. It's a great place to start. I mean, you can learn a lot by just creating a service and deploying it out there and getting it run, building all the infrastructure and support systems like your CI/CD around it, and you really get a good feel for it. If you don't have any and you're ready, you really just want to get into your current system and start upgrading and moving it. The next pattern I would say is to start to strangle it, to carve it up. Look at your application now. See what domains are in there. Think nouns in your application. Your products and your orders and things like that. And really try to carve it out. Try to find things that aren't really coupled with other systems. Things that don't talk to your legacy systems. And at some point, you're going to hit your boundary. You're going to carve out everything you can, and you're still going to left with this, this mess of legacy code. And that kind of leads into the third way, and that's really to start proxying things. If you interact with a legacy system, you still need to get data out of there, right? I mean, businesses can't live with all that mainframe systems. I mean, especially in industries like BFSI where they live on the mainframes. You can create these proxies or these adapters or these facades, whatever you want to call it, whatever way the data comes, and you basically start to interact with that proxy and have the proxy interface with the mainframe system. I mean, this gives you a lot of advantage because now that your future system is interacting with that proxy, if you want to replace that mainframe, you can easily just cut it out and it wouldn't even know because you're interacting with the proxy. I mean, it's a great way to go. And another great thing is, usually these mainframes, as I said earlier, just aren't built for the modern throughput that we see out of our machines. So by setting up this proxy in front of it, you're able to throttle those connections to the backend. You can queue them up and you can handle them at the speed that the mainframes can handle. And then over time, the mainframes can handle those requests as it can do it. And then finally, when all else fails, you can rewrite it. I mean, and eventually things are going to have to be rewritten. And I know your business doesn't want to hear that. It's a hard pill to swallow, but eventually things need to be rewritten. I mean, there's applications that are 20, 30, 40 years old, and it's gone over its life. It's time to move on, time to bury it, and time to get to the next phase. So I want to talk for a second too about your CI/CD pipeline and how important this is and what this kind of could look like or potentially look like. And I think a lot of people kind of jumble, CI and CD together, and I actually like to keep them separate and keep them split. So CI as in continuous integration, and CD as in continuous deployment. And there's all kinds of tools that are for the CI. Jenkins is probably the most popular one I see. But basically the theory is here, your code gets checked in. There's some trigger set up to Jenkins that will automatically go pull the latest code down, build it up. Then it will start to run your unit tests, whatever that automated testing suite is. And then it'll do some sort of static code analysis or linting or some sort of validation of the code to make sure it adheres to best practices. And then if we're running in a container world, it'll essentially build out your Docker container and push it into some sort of container registry. And then you would have another potential job, Jenkins or whatever CI/CD tool you're using, CI tool, to grab that container, deploy it out to your environment, and alert your testing team that it is now ready to go through. And then from the CD side, I'm a big proponent of a tool like Spinnaker, which can handle the actual deployment. And one of the great things with that is it gives you things like canary testing, the ability to take your application and deploy it out into the environment and shift some percentage of your users to the environment and see that change live in production and see how your business SLAs meet to that requirement. And if it's a success, you could roll it out to your entire organization, and if it's a failure, you can always roll it back. So some great things there. And finally, what does this look like in a year's time? If we start on this microservice journey, how do we do it so that we're successful? So, the first thing that is, you want to make sure that you pick something that you're going to succeed on. Do not take the hardest microservice that you have or the hardest service and try to get it into a microservice, because you will fail. Pick the simplest thing you can, build some confidence with the team, and get it out the door as quickly as possible. And make sure that environment is set up, stable, automated, and really perfect that. And then as you start to get that wins in that environment, you can start to go in and push that to production, start on your second microservice, and then you can start spinning up more teams from it. A kind of a good pattern is, you take your 4 to 6 developer team, you put them on the first project, you get them successful, you get that project out the door, and then once they get all that knowledge from all the tools out there, you can then take those people and then split them up and basically make them the SMEs for microservices and put them on other teams. And then now you have instead of one team, now you have 3 or 4 or 6 teams that can go out and operate. And you keep doing that throughout your entire organization to help split that knowledge. So I just want to thank you all for you having me here. And if you're interested, I did put up some links here to some of our Anthos content as well. And it looks like I have a couple minutes for some questions here. So let me see. Let me check the log here. So I got some questions. So the first is, how do containers fit into the microservice equation? That's a good question. Because if you notice, my talk was about microservices and containers, but I actually didn't talk too much about containers. So really, it's one-to-one. I mean, for every microservice that's out there, it really sees it as a deployable containers. I really thought the talk should be more focused on your application development, and like I said, I am a developer, so that is my hat that I wear. But the containers are really the engine that drives your microservice. So it's really important that you have that microservice philosophy first, and then once you do, you can easily kind of bolt on that containers. And then running the containers is a whole nother conversation that I'm sure a lot of other people will talk with Anthos and GKE. But for containers themselves, focus on the microservices, get that right, and then you can move to the container piece. Next question is, what tools or frameworks do you recommend for microservices? So, I mean, I'm been a Java developer most of my career, so I kind of lean towards that. I mean, there are a lot of good frameworks and tools out there. You really are looking for tools that essentially solve those patterns and those tools that I said before. There are a lot of good, Spring Boot, Spring Cloud tools out there that solve that. There's third-party tools out there. In fact, if you're looking at or thinking about going to GKE, the Istio route, the Istio has a lot of tools built into Istio that actually cover a lot of these patterns. They have the Istio sidecar, which does your short circuiting. It has service discovery built in. So, as a developer and as your team, if you're thinking about implementing Istio, that's a great place to start. Last question. What is the biggest blocker when working with microservices? I think it's probably the people, the process. It's a completely different mindset from, working from your monolithic application. I mean, just coming from that world of spinning up your entire application on your local machine and being able to test it, and that just goes out the window. You really need to think automation first. I mean, automation has to be the key to everything. That's really the only way you're going to be successful. So it looks like I'm out of time. So thank you all for having me. Thanks again.